Okay. Hey everyone, thanks for coming to the February Gio Community Call. Our agenda today is some updates from Elias, followed by a presentation on rendering LaTeX and similar things from Sebastien, followed by Larry Clapp and myself talking about some code reloading shenanigans. And we'll have Q&A, a short Q&A after each segment. So without further ado, I'm going to turn it over to Elias.
Thank you, Chris. I just have a short update on the compute renderer. I'll just see if I can share my screen with everyone. All right. So if anyone can't see my screen or can't hear me, please speak up or something. So I talked about the compute renderer in, I think it was 2 calls ago, where the new compute renderer is a much faster, more featureful renderer for all the rendering that Gio does. It's not yet fast as fast as the original one because Gio hasn't been optimized to use it. So the actual core renderer based on Ralph Linus's Piet GPU package is very, very fast, but all the framework around it is still using the old renderer's structures and way to encode rendering and so on. So you'll still see, at least on slower devices, that the compute renderer is not as fast as the old one, but it will be at one point when it is made default and when it is separated from the old one. So, and the goal is, of course, as I mentioned 2 months ago, is to completely replace the original renderer, because if we don't do that, then we end up with one that is fast, one that is slow, but we end up with having to duplicate all features and make sure that both of them works as well as we'd like. And so we don't gain the features and the speed up in general if we keep both renderers. So that's at least a motivation for me. I'm working straight, more or less straight for the path so that we can replace the old one with this one. So the status is, I think it was last call, I mentioned that it is merged. It's not yet default because, again, it's a bit slower in some configurations than the old one. And you can use an environment variable to test it out. Since then, I've been working on the CPU fallback, because if you can't fall back on something else, if you're running a Gio program on a device that does not support compute shaders or has broken drivers or a broken GPU or something, then we actually lose the share of devices that Gio can run on. So the idea is twofold: replace the old renderer and add a CPU fallback for the new one, so that in theory it works on everywhere that you can have that, where you can draw to the screen. And the status is that I've convinced Swift Shader. Swift Shader is a project made by Google where they re-implement the Vulkan API, and Vulkan is a newer version or a new iteration of OpenGL, which is the API for controlling your GPU. And Swift Shader re-implements all that API on the CPU. So that's what they use in, for example, in Chrome and other projects that need access to CPU features, but still need to have a fallback where the GPU is not powerful enough, or the driver is bad or not installed, and so on. I convinced that. I made a few changes, a few lines of change. You can convince that to, instead of compiling all the compute shaders and program at runtime, you can convince it to actually output object files with assembly. In this case, I have only made it so far as to output AMD64 assembly. But in short, you can take a compute program made for the GPU, use Swift Shader to compile it, and output object code that you can then embed in your Gio program, and then run that program unmodified on the CPU. And that works, but it's definitely not fast yet. It hasn't been merged yet. But it does work, which is a major milestone in this in the direction of replacing the old one. So what's the to do? I still want to add. I mentioned AMD 64 support for the phones. We need and for the new Macs, we need ARM 64, and for the older phones, we also need ARM 32-bit support in the compiler. I don't expect those two architectures to be much of a problem because, well, it works for AMD 64 and Swift Shader does support ARM and ARM 64. So I think that's just a question of tweaking the source code or adding a configuration option or something like that to Swift Shader. So the next big thing is to optimize the renderer. So as I said before, the CPU fallback works, but it's very, very slow because currently the compute renders everything from scratch every frame, which is reasonably fast and fast enough for most scenes, most apps, if you run it on a GPU. But if you run the renderer on the CPU, it's simply too slow to render. So you will get choppy, laggy frame rate and so on for anything else than the very, very simple GU apps. So the goal is to have the CPU renderer be reasonably performant on low-spec phones. And that, of course, will also help all the devices where GPU can support compute, but not fast enough so that it's just as fast as the old renderer. So it's kind of a two goals in one by optimization. And I expect most of the optimization will be in the form of caching, whatever. If you have a GU app, you almost always have a section of it, or many sections of the app that does not change from frame to frame. And my main goal is to detect these unchanged sections of your GUI and reuse them instead of re-rendering them for each frame. And I also expect that as soon as we separate the new renderer from the old renderer's encoding and way to transform and so on, we will also gain a lot of performance in that way. So the third thing, which is more of a janitorial thing than an actual requirement for replacing the old one, is that the compute shaders at this moment only supports OpenGL, which means that it runs on Android and Linux, and also it does not run on iPhone. That's my mistake. So, and if we want to have exploit the GPUs on Windows and the Apple's platforms, we'll need a direct 3D and Metal backend. So as I mentioned here on the slide, I'm working on the new architectures, the ARM architectures and the optimizations, but I would very much appreciate if someone or someone's took a look at adding a direct 3D and Metal support. And that third, supporting those two APIs is more or less completely separate from the work of the two first. So it could be done in any order. So the thorny issues is that the CPU fallback does work and it can generate AMD 64 as a object code. And I expect it to be able to just as easily generate ARM and ARM 64 object code. But it does use ccgo for gluing together that object assembly with the rest of the GU library. And ccgo is very difficult in general, very difficult to make work on Windows. And that's also why the existing backend does not use ccgo. It uses the syscall package for low-level integration with the operating system facilities needed. I'm not exactly sure what we can do about this, but something has to be done, or else Windows support will only run on Windows devices that has compute support. And the much more thorny issue is that compute doesn't yet run in browsers, and I'm not even sure that Swift Shader can output WebAssembly. But even if it could, I believe the fallback would the runtime will probably be much slower than non-WebAssembly, because in WebAssembly you don't have access to the vector instructions where you can run you can process multiple lanes of data with the same instruction, and you only have one thread available instead of all the machines thread. So Without solving number 2, we can't really throw out the old renderer. So there are some options, some possibilities for browsers. We can wait for WebGPU, which will enable compute in browsers. We can keep the old renderer for a while until WebGPU appears. There's also a possibility that we could simply use the canvas, the existing 2D canvas support in browsers. So instead of rendering low level with the 3D commands, we can translate all of the Gio's drawing commands, which are 2D, all of them are 2D commands. We can translate that to the Canvas API in browsers, where a fill is the 2D Canvas has the API that I believe is very similar to Gio. It has clip paths, it has fills, it has lines and dashed lines and so on. So that is a possibility, even though it would amount to writing a renderer just for browsers. So that's about it.
I saw Larry put his hand up. Did you have a question, Larry?
Yes. I was wondering if you can go into a little detail on how you can detect from one frame to another what has changed. That seems like it would be I don't know, hard and difficult to get right.
It may be hard to get right. My idea is to focus on, if you look at a frame from Gio's perspective, it's just a byte buffer with drawing commands. So one way to do it is to detect sections of this drawing command buffer that is the same from frame to frame. So it's sort of a content addressable cache. And of course, you don't want to just have a hash map of byte content from the rendering list of commands mapped to pre-rendered images. You need some way of encoding, perhaps a tree structure where you can walk along a command stream and then at the same time walk along a tree of say where each node is a rendering command and the leaves are the cached content, and that thereby you should be able to quickly find out whether some subset of your drawing commands matches something that you have cached already. But I haven't worked on it, so it might be a crazy idea and might not even work out. But I think it's easier to do with Gio's encoded commands than it is in many other toolkits where you have immediate drawing. What you draw is what is drawn. There's no immediate encoding and decoding step in other toolkits, as far as I know.
I think Werner has a question as well.
Hello, yes, thank you. I don't know if you know about the Molten VK project, but it does something very similar to, like instead of compiling to the object files, it compiles the Vulkan API to the metal shaders. And it's I was playing around with it a couple days ago, and you have to install like a separate library for it, but it's sort of would mean that you don't need the separate shaders in the metal, because you can just translate them. I've posted in the chat.
Yeah, sure. But there is no okay. What is the point of Molten VK as far as you see it then, in relation to Gio?
I think you would still be able to use it, but you won't be able or won't need to write the shaders themselves, because they're just translated.
Oh, okay. Sorry. When I mentioned Direct 3D and Metal support, I don't expect anyone to rewrite the shaders. I expect to use, I think it's called a SPIR-V Cross, a project where you can. Let's see if I can find it. We use it already for compiling to Direct 3D for the old renderer. It's this one. So what it can do, SPIR-V cross, is to take SPIR-V shaders, and you can compile GLSL to SPIR-V, which is kind of sort of an intermediate format for shaders, and then it can cross compile to Metal, to Direct 3D, back to GLSL, and so on. And it can also target different versions. So I think with SPIR-V cross, there shouldn't be a need to rewrite the shaders. That would be a huge amount of work because the shaders are pretty complex.
Okay, and what would be then the other task if not porting the shaders themselves? What would be the porting?
The porting would be to write the glue between Gio's compute renderer and the Metal API, for example, or the Direct 3D API. And there's actually, the glue exists already for Direct 3D that is enough for the old renderer, but there's no glue yet for specifying compute shaders and running compute shaders. So it shouldn't be, at least for Direct 3D, it shouldn't be that much of a problem. And for Metal, there's no Metal in support in TU right now, so that is a larger project, but it's not unsurmountable. It's just, I'd say, tedious, because there's probably many things that can go wrong. You can convert the coordinates wrong. You can use the API wrong if you're not familiar with it. I don't know any Metal, for example, so there can be some work in just getting to know what the APIs do and how it matches what the other APIs in TU that you uses does. But other than that, it's not a huge amount of work, I'd say.
I'm gonna time this conversation out. We could revisit this during the office hours.
Yeah.
Sure.
But I think we should transition to Sebastian's presentation.
Yeah, so let me share my screen. Okay. Oops. So last time I didn't have time to talk about how I would do draw LaTeX equations with Gio. So let's try to do that today. So it all started with two simple use cases, and one was actually to be able to render those LaTeX equations in the GNOME plot library to be able to create scientific looking plots with those LaTeX equations. And one of the things was actually in connection with the Gio Community Call, it was to be able to show those equations in a Gio GUI thing. So without further ado, how would you draw LaTeX equations? So at a very low level, if you look at it with a couple of steps, the 10,000 feet overview, it's basically the kind of the same than drawing paths or stroking paths. So once you know what equation you want to draw or to display, you just need to take out all of the symbols and the letters and where you want to draw them from the LaTeX language, let's say. And once you have that, the list of those symbols and letters, you just need to replace all of those with the glyphs which are described by the TrueType font or the OpenType font format files. And those format files actually expose those glyphs as segments, which are just lines and Bezier curves and circles and stuff that Gio knows how to draw once you have the stroking paths API. So once the LaTeX equation has been properly parsed, you just have to give it to some library which replaces all of those pieces, text pieces, and replace them with operations and commands to draw the paths. So in a TrueType font or in an OTF font, what you have is for each of the little characters that you want to draw, you have a set of commands, so and informations and metrics associated to the font and each of the glyphs or characters. So you know the bounding box, so the rectangle in which you have the letter being completely, which can be completely written in or displayed into that bounding box. And you have also all of those pesky little details on the baseline, which is the line on top of which you want to draw the letter, and also the extent of that letter vertically, so upward from the baseline and downward from the baseline, for example, the Q of the Q, and also the width of that character. So once you have all of that, all of those information which are embedded into the text font, then you can try to pass that information and convert that information into the Gio commands, and then pass that into some Canva. So that's the 10,000 feet overview. I've created a little package called Go LaTeX, and under which you have a couple of packages. The first one being mtech for math tech, which can actually parse LaTeX equations. So I've implemented a lexer and parser and tokenizer. And then with this parse method, given an expression string, which contains that LaTeX math equation, it will spit out an abstract syntax tree of nodes, LaTeX or tech nodes, which will then be able to be translated into an image or a PDF document. So then there is this tech package which takes that AST tree and will apply all of the somewhat complicated tech formulae to be able to implement the typesetting from tech, which, well, for some definition of good, looks good. So compute the boxes for each of the letters and the mathematical symbols, then expand or shrinks all of those letters so they look good on the screen. Also, it deals with all of the alignment of each of the symbols together within this mathematical expression. So all of those quite sophisticated algorithms which make tech look very good. And then there is a function which takes that expression or the AST and then will spit out or render that expression to some wrnrlr interface, which has been implemented for an image in the draw image package and a PDF document in the draw PDF. And then I've also implemented a Gio backend, which I just put into the mtech render command, which allows to have a batch-like approach to spit out the PDF or image equations, or a Gio backend with a GUI mode. So here is a little rendering of that GUI, and let me try to do it just like, oops, no, that's the wrong one. Let me try to do it live. So I hope that you see it correctly. So you have, with this mtech render GUI, you have a little field here where you can type your LaTeX equation, and then a big blue button to render it here first as an image, and at the bottom of the GUI, you have the same thing, but using the Gio renderer. And let me remove something so that you see it's not just and that it's quite fast also to render. So that's using the Liberation font, which I've just hard-coded in there. Of course, the Liberation font is not, well, it has some mathematical display and symbol facilities, but it's not, I would say, the LaTeX experience, which, well, scientists love. That's usually done with the quote-unquote official LaTeX font, which is called the Computer Modern, from the original tech distribution. And unfortunately, that font is using some quite old format, which is called the tech font matrix format. But people have tried to translate that one into a open type font library, and that's called the Latin Modern font, which I've been using here. But as you can see, there are a few, let's say, bugs, which doesn't look very good. I mean, my little MTech and GoLaTeX package doesn't handle very well that Latin Modern open type. That's because there are a few, let's say, magical numbers to apply as factors and scales to be able to correctly handle spaces and translate the tech metric font stuff into an open type or more modern tech font, true type font. So that's still kind of a work in progress. But, well, apart from that, it's kind of working. Okay. So yeah, that's I've already said, kind of already said, it's a work in progress. The GoLaTeX package is actually using the same algorithm which was written by the Matplotlib folks, a Python library to do plots in Python. They implemented the algorithm for to do text typesetting, at least a subset of that. To have that kind of look and feel from the LaTeX world. And I've tried to do the same in GoLaTeX. But the problem is that it's, while it was quite fun to implement that tech parser and the mathematical equation parser, it's not a complete tech engine. So, well, there are some differences between the rendering, I mean, bug-free, without the bugs that I've added. There are a few differences in how the Matplotlib or GoLaTeX and tech packages do render stuff compared to the original tech engine. There are also a few bugs in my mathematical equation parser. For example, at some point it didn't parse correctly mathematical equations where you had a floating point number because the point was not correctly handled. So it's not a completely satisfactory situation. And also because I had to implement by hand a subset of the real LaTeX mathematical equation language where each anti/something function had to be implemented by hand in Go instead of just giving it the tech definition and it would just magically translate it into Gio or PDF commands. So at some point I realized that the best course of action was to implement a real tech engine completely in Go. And I've started to do that in that package on the source hut repository, star-tex. If you, I mean, sorry for the bad pun, but it was one of the only pun with wordplay with tech which wasn't already taken. So the aim of that star-tex package is to have a complete tech engine in pure Go, which is completely compatible with the official one from the TechLive package, so either LuaTech or XZTech, and have the output being bit by bit compatible with the TechLive one. So I already have something which is kind of working here. You have the star-tex command, which can take a plain text file, hello.tech, and will spit out a DVI file, which will be translated into a PDF file using the TechLive command DVI PDF, and you have a screenshot of the rendering of that stuff. So it's already handling a couple of equations and the typesetting of paragraphs and sections and stuff from LaTeX. So I'm already quite happy with it. But the thing will be, of course, to replace the C stuff, which I'm binding to have a complete pure Go stuff. Yeah, so that's just the little a peek at the future to be able to perhaps have a Gio-based application where you can completely clap set a PDF file from a tech document. So that's all I have for now. Thank you.
That is awesome. That seems like a rough journey through some of that, especially the font, the old LaTeX font seems.
Yeah. I mean, there are already some CSS tricks that you can play with to have, for example, a complete website look like a LaTeX document. But being able to do all of that in pure Go is something that well attracts my scientist inner self.
Sure.
And my gopher side also, of course.
All right. So I just threw this out for your later perusal, but the ccgo project that was recently shared in GUI in Slack may actually be handy. I don't know if there are parts of the LaTeX infrastructure that you want to just lift and shift into Go. You might just be able to compile them into Go.
Yeah. I've been following that that project from the Modern C site with. I mean, I've been quite interested in following that. The thing is that ccgo is only working on Linux AMD64. So you can't cross-compile from the Linux box to any other architecture for the moment. I know that Sysnic is working on a Linux ARM64 port, if I'm not mistaken. But well, until now, for the moment, it's easier, or albeit tedious, to look at the C code generated by the TechLive distribution and bit by bit replace that C or C++ function with a Go function. That's the plan, at least for starting.
Fair enough. Well, I admire the dedication. I know that takes
weekends.
Well, does anyone else have questions for Sebastien? Okay. Well, thank you so much for sharing that. I mean, it's the thought of not having to install the whole TechLive distribution to do anything with LaTeX is heartwarming. I'm excited for that. So next up is a joint presentation between Larry, Clapp, and myself. So Larry, if you could go ahead and share.
Okay, dope.
Yeah, so it started when I built this. I don't know, Larry and I were coincidentally both playing at the intersection of Yagi, which is a Go interpreter, and Gio. We both kind of wanted to see, can we interpret part of a Gio interface at runtime? And so this project is kind of, this demo is a simple self-contained thing that does that. So the contents of the editor on the left are, whenever they change, interpreted by Yagi, and then the new definition starts being used on the right. And so Larry just changed the denominator of this fraction that's involved in the math of the rotation. And so you can see a couple of important things. You can see that one, it had an effect. The right-hand side immediately changes its rotational speed. And now we're changing where we're rotating it around, or yeah. But the other really important thing is that whenever Larry makes a change, the word hello resets to its start position. Because what we're doing whenever we change something, and so here we've stopped invalidating. So now the animation's horrible and choppy because it only animates when the cursor in the editor blinks. But the word hello gets reset to the start state because in order to update this layout function, we actually have to take the state of the Yagi interpreter it's running in and totally throw it away and start over. We're spawning an entirely new interpreter each time. So if we just like removed a letter in the word hello, we have to reparse this whole thing, jettison it, and start over. And that means that the value of the rotation variable gets reset. That means that, I mean, we do a lot of work in order to achieve that. And so this kind of sparked something for both Larry and myself where this is cool. I think that this exact approach might be a really exciting way to build a browser playground for Gio, and I intend to pursue that soon. But we really wanted to see, can we reload interfaces without losing all the state? You know, what exists in the intersection of that? And so this talk is going to be kind of a journey through what we've done in the last couple of weeks in that space. The kind of crucial insight that set us down this was Larry pointing out that there is a kind of simple transformation you can make to Go code that allows the methods and functions to be redefined at runtime. So if we're interested in like a very simple file, do we have the unrewritten one that we could do a side-by-side on? So if we're interested in redefining this function f1 on the left at runtime in Go, we obviously can't reassign the definition of f1. The compiler and Yagi, the interpreter, both do not allow redeclaration of the same symbol. However, on the right, you can see we still have a function. It's still a function. It's not like a function variable. It's still not redefinable, except now its implementation depends on a variable. And so because the implementation is a variable and we've shifted the body of the function into that variable, it is now possible for us to invoke this like setter function at runtime to redefine the implementation of this symbol. So what we wanted to do was to build tooling to automatically apply this transformation to your code base, and then to help you watch your source code. And whenever you make a change, if it's possible for us to reload that change live, to actually do that. And so I'm going to let Larry talk you through the demo that he's got running and how it works now.
Okay. So I'm not muted. Good. Just saying, so we wrote some tooling to take this left side and generate the right side for a given specified set of packages. Can you all hear me? I lost all feedback.
We can hear you. Yes.
Okay. Sorry. Thanks. And there were many challenges. We went down one kind of not quite dead end exactly, but we used one of the earlier versions of the Go type checker, and it turns out the later version was quite a bit more friendlier to interact with. And we discovered along the way that you have to do a lot of things. You have to find every private variable that's specified at the top level and make it public. We've done that by adding a GRL prefix to most things. As you can see for the functions, I was already exported, so we didn't have to add anything to that, but we export every private variable. You have to find all the top level, well, any struct definition, and export its members. So there's a lot involved. And we're still not, we still don't quite have everything. I actually discovered a bug just late last night where if one of these functions has like a ... kind of thing in it, something like that, we do not translate that correctly. Just as I said, I just discovered that last night. That's not in any of our sample code, so we haven't even tried it yet. So this, the parser is right now, it's, we initially went down a road of trying to use a Go compiler facility called tool exec, which basically allows you to run an executable sort of in the middle of the Go compiler. When Go runs a compile, it'll run your tool exec program instead. And this allows you to do a lot of nifty things, like translate these files more or less transparently. That ends up being really hard though, because there are other limitations. Like if your translated code needs to add a dependency, add an import, add a new file, the compiler doesn't like that because it has already figured out what the dependencies are and where they go, and it doesn't like it when you add an import that it doesn't expect. So basically, fairly recently, we rewrote it to be frankly, much stupider, but on the other hand, it's much more easy to understand. And so, for example, my Go path is in this source Go get. We're in the the got reload repository in the demo tree, and basically, where's my tar file? So I've got a command all set up to tar up everything in this tree, copy it to a different tree that I've called GRL. But other than that, it has exactly the same structure. And then it runs the got reload filter on that directory. And it says, watch for these packages to change. So I'm going to run that now. And I apologize, we have some construction going on in the background, so if you can hear that, well, sorry about that. So
It's
you can see that it wrote.
through.
Okay, good, excellent. So you can see that it writes out all the files it generates, and it writes out also some special, what we call registrations. And I'm gonna, this is that tree. I think that's what this window is. So, for example, it writes out all this stuff, and it also writes out something for something that Yegi uses to allow a Yegi interpreter to access these functions. There's no way using the reflect package, at least not that Chris and I could find, that says, you know, let me iterate over all the exported variables and identifiers and so on. So you have to pre-generate something that says, if somebody references the text f1, that's actually the value of this variable. And if somebody references the text of grl set f1, that's the value of this variable, and so on. And with a more complex file, you get a lot more here. And so we have the translations of the example.go function, file. We have the registrations for it. And we have the example2 package, which is even simpler than example1. And we have its registrations. And so before I get into actually running that, as I said, things are kind of still not very polished. The README has some better ways to do this, but basically, or at least some better ways, easier ways to specify this. Right now, we communicate with the rewriter via environment variables. We say, here are the packages we're interested in, a comma delimited list. Here's the source code directory that we want you to watch, and here's just sort of a, it's a signal to tell the reloader to actually run. I was worried that if you didn't have this and you were accidentally in the wrong tree and running it, you might run the reloader accidentally, and we might remove that. Chris and I haven't talked about this particular facility all that much. As I said, it's sort of broke and that all the wires are exposed. But anyway, so what we see is that the reloader runs a go list using this as the as current directory, which you'll notice is different than the shadow directory I'm in. So it runs a go list and says what package am I in, what module am I in, what packages are available, and it uses the reload packages environment variable to say I'm going to watch this path and I'm going to watch this path, and our stupid little demo program. Oops, keep doing that. Our demo program is also fairly stupid. It waits for you to press enter in a loop, and then calls some of these example functions in that loop. And this highlights one of the limitations of this approach. As far as we can tell, one of the fundamental limitations is that we can't do anything with functions that are in main, because, as I said in one of these like registration files, you have to be able to give it a package, a specific variable, when you're giving it when you're calling reflect value of. And from some other package, there's no way to reference this package's main package, or this module's main package. That's one of the fundamental limitations of Go. You cannot reference the main package from anywhere but the main package, and you can't like say main dot whatever like you can with some other package. So in this context, for this demo, all the code that we can rewrite is in the other example packages. I'm going to show you the Gio hello example in a minute, and actually I think it takes a similar approach, but the kitchen example takes a different approach. Anyway, so we've got example f1, example f2, example.i, and these are all printed out. And again, this is from my core Go get source code tree. So if I press enter, we see some stuff that's you see just the basic code, and I can also change this, for example, format to a log, and then save it. And the reparser notices that the file changed, and because I'm using them and I backup set, it like writes a new file and then writes the backup file. So we get 2 change notifications. So we actually installed a debouncer that waits 1/10 of a second for things to calm down. And then it says, okay, I'm going to reparse example.go, and I'm going to say, this one function appears to have changed. One function changed, so I'm going to rerun its setter function. So now if I press enter again, we see that this printed out using log just form. We also see that we have this context I. I is printed out here in the main loop, and it's on the last line, and we see that I 1, 2, 3, 4, 5, 6, 7. I has not changed. We have not reloaded the entire file. We've only reloaded this particular function. So we can change what code we call. We can change how the code runs. So now I decrement. So now it's gone down from 7, 6, 5, 4, 3. So there's that. And as I said, that's we can also change like just what it returns, obviously. So here we have example F1 is now returning 3 instead of the 1 that it was returning before. Notice I'm not actually passing anything into F1 or changing what I'm passing. As far as we know, that's another fundamental limitation. We cannot change the signature of a function. If we did that, we might eventually be able to, but right now we can't. If we were able to, what that would involve is finding everybody that calls it and updating them, and then having all of them call essentially a brand new function that looks like F1. But from the Yiggy's interpreter point of view is actually a completely new function. So that's kind of it for that demo code. Let's do something a little more exciting. This is the Gio example hello code. So I took the hello code out of the main function and put it into a package called package, which is quite creative, if you ask me. Just kidding. So I translated that, and now we're running that. And I found that it's handy when running multiple instantiations, multiple instances of all this to show me what it's configured to do at any given time. So that's that. That's for me and for you. So start the reloader. It's watching this tree. So here's code. I think I have that loaded somewhere. This is also the demo. Apparently not. Oh, no, I take it back. I think I codified it way down here. That's the view example hello. Here we go. Okay, so this used to have some code inline for a system frame event. I moved that to the PKG package and just called frame. Frame looks like this. And one of the interesting things about all this is that you can redefine this function and nothing happens unless Gio redraws it or calls it again. So I added code to hello to invalidate every second. So let's actually give that a shot. So do that. Oops. My Vim commands are looking a little weird. So see if I can get all those on one screen at the time. So we can see, found the hello file changed, it reparsed it and ran grl set frame, and then a second or so later it was invalidated and called that function again and got the new value. So we can do that, and it changes, and we can change the color, say, and it changes to a bright red, or that didn't seem to work. Red, green, blue. Did I do something wrong there?
I'm not sure if it's saved.
Oh. Well, let's do something back to this thing. Well, as you can see, still a few things to iron out. Oh. So it wasn't invalidating. So how does that?
You can always add an invalidate op to this function if you don't mind burning through your GPU.
No, it did. Oh, that would be a lot of invalidates.
Yeah.
So now I'm not sure what it was doing before, but it seems to be working now. One thing is the part of the reloader that detects whether something has changed. Basically, it parses the tree, does a miniature gofumpt to output it to a string, and just does a string comparison. That seems to work. There may be some issues that I've missed. You wouldn't think it'd be all that hard to get a string comparison wrong, but apparently I did, because sometimes it wasn't reloading, or possibly it just wasn't invalidating. I'm not sure which. But anyway, so we can see that we can change a lot of the stuff in this function. It would be problematic to change the signature again, but you can add stuff. Like there's nothing in here. We don't import the FMT, but we can. We go back to our terminal, and now we see that we're getting a hello world every time we get an invalidate. So we imported a new package. That package was automatically inserted into our source, and the reloader detected the new package in the function and imported it automatically. So I'm going to delete that. And let's see. Let's look at some of the generated code for that. If I can.
We're coming up on time, so.
Okay. Moving quickly then. Let me show the kitchen. And I want to show kitchen in part because it doesn't work. Basically, right over here. Got load demo. There's the kitchen. So I rewrote. I just put everything into a different package and ran it. And it turns out that, as near as I can tell, this is a Yegi bug. It doesn't really like this, where we take a layout widget, which is just a func of context returning dimensions, and sometimes we give it that kind of func, and sometimes we give it a function literal. But in no case do we give it an actual layout widget, and Yegi doesn't like that particular Go construct. If I tried to edit this, sees that it changed, it reparses it, and it says, I got an error interpreting this, and it says, can't use type blank, and I think that's another Yegi bug as this type. So as I said, there's still some other things to get right, but it's still, we feel like it's a very promising technology, promising project, and we hope that it will be able to basically do arbitrary GU code very soon. This has all been in the last 2 weeks. I don't know about Chris, but I spent more or less most of my non-work waking hours working on this, or obsessing over it, or losing sleep over it. It's been an exciting ride. I guess thank you very much. Are there any questions, Chris, or do we have time for that?
I think we can afford to take a couple of minutes for questions, and you can, we can put the repository, or yeah, if you could just show them where it lives.
Oh, stop sharing, that's what I want. Where's that?
The repo is here in the chat.
Right. That's exactly what I was going to do. So thank you for that. So yeah, that's a got reload. We created our shiny new organization for that. The name may yet change. Got reload is our second name, or it may not. We don't know yet. Anyway, that's what we have so far. Hope you like it.
Any questions on that before we transition to
short
office
question.
hours? Yeah.
What? So the Go compiler, is it that much slower to use than the Yagi interpreter?
So
is the point of this project to maintain the state between updates or something else?
The point is to maintain the state between updates, yeah. So
Elias, what you asked is the Go compiler slower than Yagi? I think you meant the reverse.
So are you suggesting that there is a trivial thing that we could be doing with the compiler?
No. I'm just wondering what is of your design constraints of this.
Okay, yeah. So I can talk about that some. So Go has like the plugin. Okay. So the design constraints were the Go plugin mechanism doesn't work for all target operating systems. Like you can kind of dynamically load Go code, but only on Linux and Darwin, I think. And since Gio and Go in general tries to target a lot more platforms than that, that didn't feel like the right first approach. I think another strategy is to compile as C shared libraries and dynamically load that way, but then you have to go through ccgo every time you want to access your dynamic content, and that has its own set of kind of pain. I don't think that we've explored that option very deeply, but it seemed awful. Whereas from our experience working with Yagi, it was like, obviously there's still some friction in the Yagi integration, but it's been pretty painless. We're doing everything in pure Go. Mm-hmm. It's much easier to reason about. And the transformations we're making to the source code are simple, like compared to what we might have to do for ccgo. In the future, I hope that we can add support for both other Go interpreters like Go macro. And I would like to add support for the plugin Go mechanism on platforms that can use it, because I do suspect it's a lot faster, especially the end result. When you actually compile the code, running those functions is going to be faster. But yes, Beben in the chat, this tool is designed to work with Go in general, but the use case that's near and dear to our hearts is Gio interfaces. I would love to bring this up to the point where you can fairly painlessly edit a Gio interface, much like editing a browser tab in the web inspector, changing the CSS and watching it change in real time.
Yeah, that's the most cool about that project for Gio, I would say. It sort of sidesteps the issue of having a visual designer for Gio.
Right, exactly. You can add stuff. You can play with layouts live. You can play with lists live. You can say, oh, what did this list change I just make do?
Honestly, I just want to be able to, make little inset changes and like change padding and align things without restarting the whole program and like navigating back to the part of the interface I was looking at. But yeah, we think it has a lot of potential. So
it looks like it. It definitely looks like it.
Yeah, we expect it'll be standalone and aren't looking to try to integrate it with Gio.
Though I would love to have a separate package that you could deploy into your Gio application during development that would spawn another Gio window that was a control plane for this facility, to kind of let you tune some of the behaviors around the debouncing and the like how it decides to reload and what kind of like status feedback you get from the reload process. But that's a future thing.
Yep. It's also, I mean, blue sky, if we're, as long as we're talking like, this is my fantasy world, is where we'll be able to embed the source into an application or into some other binary image, and you could like actually ship it. So that might be, we could make Go behave a bit more like, you know, a small talk image. But I don't know. That's obviously far in the future.
And also, don't do that on iOS, or you'll get us all banned from the App Store because you can't have dynamic content. All right. Yeah. So that kind of concludes that presentation. So that is the end of our kind of scheduled community call content. And thank you for coming. I'm going to stop the recording and we can transition to more of an informal office hours.